Okay, then we can start. It's 4 o'clock. First of all, I will share my camera. Hello. Hello, everybody. Welcome to our today's training for students, RFEM 6 training for students. My name is Juliane Stopper. I'm working in the Dlubal team in customer support, and I'm also working for the developer teams for geotechnical analysis add-on, and I'm supporting the concrete design team. Today I will give this training to you. But for this, we are not alone. I have my colleague Walter with me, or we have him with us. Maybe Walter, you also want to introduce to yourself. Walter, I don't hear you.
Jetzt?
Yes, no.
Okay. I also would like to welcome you to today's training. My name is Walter Fröhlich, and I'm responsible for customer support and for the development for the add-on steel joints in RFEM 6. Today I will answer to your questions in the chat.
Okay, thank you, Walter. Yes, then we will start the training. I will share my screen and we will close our cameras so you can see my screen, full screen. I'm closing my camera. Walter, which screen do you see? Do you see the presentation or RFEM 6?
I see RFEM 6.
Okay, I need to change this. Okay, I think now it should be the presentation, right?
Yes, it's correct.
Okay,
No, it's
then we
correct.
can start. Fine. Yeah, we introduced ourselves. We are in the training for students today. At first, we have from webinar, go to webinar, you can see this panel. Some short words to this. You can hide this panel if you want to see your screen only. If you have some sound problems, you can check, do a sound check here. And this is the chat window where you can ask your questions and Walter will see them. So yeah, this so far. Then we can go to the training. Yeah. Our online training for students is a series and contains these parts. And today we are in part 5 in the concrete design training. Yeah. And the today's training is divided into 2 parts. At first, we will have a look at an introductory example, the concrete beam. And the second part will be the design of a concrete slab. Okay, so and now we will go to the program. I open RFEM 6. 1 minute. Okay. It's a new window should open. I'm sorry, I didn't open this before. So here we go. Okay, so this is RFEM 6. when you open it, and I will now start a new model via this button. And when we do this, we come to the base data of the model. Here we can give it a name, and I will call it our example number 1. It will be a concrete beam. And we won't change any of these details. We will just have a look at the next tab at the add-ons. Our program RFEM 6 is a finite element program. With that, you can calculate stresses, strains, inner forces, and deformations for structures. And if you want to do a design, you need to activate the specific design add-on. And today we will go to concrete design, therefore I activate it. And what you have to do then as well is you have to define the standard for according to that you want to do the design. And here we have as default the Eurocode and the SEN annex, and we will keep this for today's online training. And now we define the base data and a new empty model is opening. Okay, so yes, this is our model, and we can now go along the navigator data to define all the input that is needed. RFEM 6 is generally keeping some example or default materials and sections from the previous models, but I want to start today with you from an empty model. Therefore, I delete all basic objects that we have here so that we can start from 0. Okay, so the first point in my navigator is the materials, and this is where we go now. We will define our materials. I open the dialog, and here we can give the input. You can directly define input here, or you can use the library. The material library can be opened via this button here. And what I want to have first is my concrete, and we will use for our beam C3037. I agree, and I have my concrete in the list. Then I want to define the reinforcing steel. Therefore, I open a new material, material number 2, and again I am using the library, and I can change here the material type. Now I want to find the reinforcing steel, and I will take the B500SA for the rebars, and then I have my materials in the list, and I can see the material properties. And now I agree, and I have my concrete and my reinforcing steel in the model. Okay, so the next point in the navigator is the sections, and we also need to define the section for our beam. So I open the dialog for entering the new beam. And here we also have the option to go to a library. It's a section library. We have different here. And also we have a pre-selection here where you can directly take one or select one. We today now want to use this rectangular cross section, so it's fine for me. The program also selected the first material of the list. It also fits for us, so we keep this. We don't need to change anything on this tab. We go to the second one, and here I can change the dimensions of the profile. And in my example, the beam has a width of 300 millimeter and a height of 450 millimeter. Okay, and this is it. My cross section is defined. The objects in the list of the navigator are generally shown in black color. If it is blue, it means that this object isn't used yet in the model. So my concrete is used by this section, that's why it's already black. It is something that can help sometimes to control your input. If you see something is blue that you actually wanted to use, then you know you should check this more in detail. Okay, so now we have the materials and we have the sections, then we can define the geometry of the beam. Therefore, I have this button here. I'm clicking on it and I can, I want to define a member, and there you can select a member type. We have here beam, and we have other types also, like truss, you know, and different, but for us, we take the beam today here. Then in the second tab, we have the section. The first section of the list is assigned, it fits for us. So we can agree and define the positions. I'm starting my beam from 0, and it shall be 8 meters long, and I can use the raster like here. Okay, it's 8 meters and my beam is finished. I can also zoom it now, so it's shown full screen and I have my beam here. So now I have my geometry. Now what we need is the supports, the boundary conditions, the geometrical. I will have one support at this node. So I double click on this node and I come into the dialog of the node, and here I can say as an option that this node shall be the position of a support. And I will assign a support here. I have to define a new one. And I'm choosing a fixed support for this point. And I can say OK, and then I can see my support here. My next support shall be placed within the beam. Therefore, I want to use an option that is contained in the beam. I double click on the beam, and again I'm in the dialog for the beam, for the member, and I can say here I have the option to define nodes on member, and this tab opens then, you see. Okay, so we go to this tab, and I want at a distance of 75% of the member, it's 6 meters. I want a node. Now I have this node here, and I can assign there a support as well. I double clicked on this node in the dialog and can give a support. Here I want another support. I want a sliding in X direction, and I also want to fix the rotation around X axis, the torsional rotation. Okay, say okay. Now I have my supports. Then we can have a look. Here we don't need from the navigator further points of the basic objects. Also, I defined the supports. What we need now is loads. Therefore, I can go here to this point in the navigator, and I go here with right click to load cases and combinations. We have the combination wizard activated. This means the program generates our load combinations according to the standard I selected. I go to tab load cases, and here we have as default a first load case that contains the self weight of the structure. And in here the self weight is activated. This means with the cross section and the specific weight of the member that the self weight is calculated. And I want to have another load case. This will be my live load in field 1. So I call it live load 1. And I need to change the action category so that the combination wizard is doing the right thing. We have an office area, so we take this. I want to have another live load in field 2. And it's the same action category, so I copied this for the second load case, and only I changed the name for live load 2. Okay, then we can have a look at the other tabs. Here we can see the action categories that are contained in that model, and here we can see design situations. We have, as default, these 4 design situations defined. Today in this model only I want to solve the ultimate limit state design situation. You also can have a look at the combination rule that is used within this. It depends on the code the standard you defined. And I want to solve this one. These I don't want to have in the model, so I deactivated them. Now this and this will be considered in the concrete design. Then we can see here the prepared action category, action combinations, and from these the load combinations are generated. These are the load combinations that are checked within the design checks for the concrete design. I want to also change the analysis settings for this for these load combinations. You can do this here. I want to solve it geometrically linear. This is enough and fine for our beam now. Okay, so now I defined load cases, but I have to fill them with loads. We can see that here in the navigator, our load cases are shown, and they are empty. I have to define the loads. I also can see them here. And we have one load that is already there. We can have a look at this. If we go to Navigator Display, here we can activate the self-weight. And now we can see the self-weight that is automatically calculated, as I told you, by activation of the self-weight. I want to assign another dead load. Here, therefore, I can go from here, but also I can use this button here. I want to show you this button. We can define a new member load from there. Here, the load case is selected. I want to put another load into load case 1. It shall be assigned to member number 1. And it shall be 1.5 kilonewton per meter. And I can say apply and next. And then I can see it was added to my load case 1. Okay, now I can go to my second load case, live load 1. And live load 1 shall again be assigned to member number 1. So I write the 1 here. Okay, and I want to use another load distribution type. I want to use trapezoidal, and it shall be 20 kilonewton per meter in the load distance between 0 and 6 meters. So I apply this and say next, and now I can see for my live load 1 the recently defined load. Then I can again change here my load case and define live load 2. It shall be the same load magnitude, but another load distance. I choose 6 meters to 8 meters for member number 1. Okay. So this is it. I have my loads defined, as we can see here, and we also can have a look at our load combinations, for example, this one, and then we can see the sum. I mean, it's not the sum, but the factored loads. Okay, so now we completed the input for the finite element analysis, but we also want to do the concrete design. So now we will check the input for concrete design. We can therefore click on this member, and here we can see that design properties are available and currently activated. It's because it's a concrete member, so for concrete design, design properties can be activated. If I deactivate it, I can see the tabs that belong to the member. And these come from concrete design, and we will have a look at them now. These are only available if we activate the concrete design add-on. Okay, so the first tab is the concrete effective length. This is needed if you want to do the stability design checks and use the equivalent member method. We don't need this for our member, so I go to the next tab, to concrete cover. Here you can select a concrete durability class. I will show you. Here you have also this image, which helps from time to time. And as default, we have XC1 class selected, which is fine for us. And from the selection of this class, this minimum concrete cover is given. You can use the standard, the minimum concrete cover according to standard, but you also can use a user-defined value. You can activate this here, and if you want or need, you also can define user-defined values different for the section size. Yeah, but for us now, according to standard is fine. So now we can come to the reinforcement. The first tab contains the shear reinforcement, and here we can give the input that is needed. At first you can select a stirrup type. We have other types, like for example 3-legged, but we keep the 2-legged now. Then you can give the bar diameter. I want at first start with 8 millimeters, and the distance is 30 centimeter, and the program automatically solves that we have then 27 stirrups contained in along the length. You could also add here more different zones for the member to define different stirrup reinforcement areas for different parts of the member. But for us now it's okay. I will show later how to edit this. We go to longitudinal reinforcement. Here also we can change the rebar type, and here I want to do it. I want to do and I want to use the unsymmetrical type. This allows me to define different values for bottom and top, which is for us a good choice. Okay, I want to have 0 bars in the middle. I want to have 3 bars of diameter 20, and I want to have 3 bars of diameter 14 at the top of the beam. And as an information, I also get here the reinforcement areas that are now placed in my beam. Yeah, this is it, what I wanted to prepare. Then we can check the next tab. Here we have the design configurations. And there's a configuration for ultimate limit state and for serviceability limit state. And at these you should check. You can go there. And here a lot of settings are done for the design checks that come from the standard you are using. For example, some detailing rules according the minimum reinforcement. Or what we also use is a reduction of the shear force at the support face at distance D, for example. And you also we can deselect the design of shear joint. We don't need this for this member. Yeah, like this you should have a look also. And there's another default settings for serviceability, but this is for us now fine. Then this tab contains the design supports. We need design supports for concrete design, for example, for deflection calculation, or even for this reduction that I showed you. You need information about the dimension of the support, and therefore we define it now. I open a new one. It shall be a concrete support, a monolithic connection, and no inner support. I need this for my support at the left side of the beam, and I will have another one which will be an inner support and not monolithic. And here we can see also the support width. I keep the default setting. Okay, and here we can see our monolithic support at this point. And at the end of the member, I don't have a support. I have an inner support here at this internal node. It's this one. And I don't want to have support in y-axis for the second one. I also need to deactivate this. Okay, and now I see my design supports that I defined. It's okay. I agree, and I have them now. Okay, so my beam is prepared. We can see the reinforcement here. You also have from the add-on concrete design in the navigator this folder and this folder. And here some concrete design settings are selected, like the durability classes, or here the configs we had a look at. But for now it's okay for us. So our member is ready to be solved. I'm using the table window here, and there we can select concrete design, and I can see the design situations that I activated, and I can press on this I want to see results and agree that the calculation is started. Now the program solves all the load combinations that were defined and that are needed for the concrete design. And the concrete design is done afterwards. Okay, now all design checks according the selected standard were done for this beam. And I want to change my graphic settings. I don't want to see the loads now. I'm choosing here the wireframe model, and I will deselect the reinforcement so that we can more easily see the results. And what is shown first is the overview, and it's at first you can see red, but don't worry, you can here select design ratios on members, and there you can see there's also a lot of design checks that are fulfilled. And now I have mainly one question. At first I want to see my ultimate limit state ratios. Can my member carry its loads or not? And therefore I can here select the display in the table. Now all checks that are done are contained in this table. Even detailing and of members and particular rules is shown. You can deactivate this, and also the serviceability limit state. And here you can see the ultimate limit state checks. And there we can see we have a problem in UL01 in the section resistance. And at this, we want to have a look now. What is displayed here is a ratio envelope that envelopes all ratios. I want to now check my section resistance design check, and here I can see I have a problem at this support, and I guess it's from the moment of that support that causes tension at the top side of my member. We remember that I defined stronger reinforcement for the bottom side and for the top side not, because in the field at the bottom side is needed. So I guess this is the problem. Now we can, on the one hand, have a look at the design checks. We also can have a look at the reinforcement that I want to do now with you. We can see which reinforcement is required at the top and at the bottom. This is the required reinforcement. Here we can see also on the panel. And now we can see what did we provide. What did we provide at the top and what did we provide at the bottom. And now I can see at the top, close to the support, I don't have enough reinforcement. I need to change this. And you can use this graphic. You also can directly check the not covered reinforcement. And we see at the top, at the bottom it's 0, everything is covered. At the top, we can see that we need 4.8 centimeters square more. So therefore, I go into the design properties of the beam. I can just double click on the beam and I am in the dialog for editing my member and its design properties. And here we go to the longitudinal reinforcement. And I want to define additional reinforcement. Therefore, I'm defining a new item. I don't want to change the item I have there. I want to add something. And again, it shall be of type unsymmetrical. And I don't want any reinforcement at the bottom. I want it at the top. And I'm using 16 millimeters as diameter. And then I want to also, here I can see the area and I can see it's enough. Yeah, we have 4.8 missing and I add 6, so it's okay. I want to define an offset type from stirrup. I want that it's from the top side moved 3 centimeter, and I can see now it's placed here, my additional reinforcement. And also I want to change the length of my reinforcement, because here in the graphic we can see now we have additional reinforcement along the whole length. This we don't need. I will define it from 0 up to 2.5 meters. And now we can see our additional reinforcement. This is what I want. You have here the option to click on this button. This is nice. It shows the whole reinforcement of the beam listed, and it's a good overview that is given, and you can print from here to graphics, to print out report, to PDF and so on, whatever you need. Okay, yeah, and here also in the shear reinforcement, you could add different zones. Then you have different zones where you can change the reinforcement. But I will keep the distance and the diameter. I will keep it as 8 because there was no problem in shear design. We also can have a look at now. Okay, now I added my longitudinal reinforcement and I can solve again. Okay, so again we are in the overview and I go to design ratios on members and I can see now my ultimate limit state checks are fulfilled. Yeah, I can see in the design checks that my ratio is fine. My reinforcement also I can see the not covered reinforcement is 0. And I have here, we can have a look at the provided and we can see our additional reinforcement here at this part of the member. Now I want to show you, we want to have a look at the shear resistance. It's this check UL02, and we can do a double click here. And if you do this, you can come to the design check details. This is quite a lot of information and very detailed. Here you can see what is done within this check, and you have the related chapter of the standard given, and you can fully follow the check, and you can, if your check is not fulfilled, you can have a look where is the problem or what has a big influence. Yeah, you can find all the information here. And yeah, you can also have a look at the section, for example. This is the section at position 0. So what we see here is that we have tension in the upper part of the cross section and compression at the bottom. And then you also can change the position. We can go, for example, to the middle and again have a look at the section, and now you can see that it changed. We are now in the middle of the beam, and we have tension at the bottom side and compression at the top side. You yeah, can also change the view here. Yeah, normally it should work. It's a bit more slow with GoToWebinar. Okay, I close this. Yeah, you also can show result diagrams for the member, and you can have results along the member. You can here check the concrete design, and you have all the checks that you can see in the main window again for one member displayed here in detail. But yeah, this I just wanted to show you. You can check the design check details. There's a lot of information. It's yeah, this is it. Okay. This is what I wanted to show you with the concrete beam. Now I want to also have a look at a slab with you. Therefore, we shortly go into the slide. I just want to show you what's the topic of the analysis, the object of analysis. We will have a concrete slab that is supported by columns and walls, and we have here ribs also that are placed there, and we have here the materials listed. We have a C3037 for the slab and the ribs or L beams, and we have a C2530 for the walls and the columns. And we have two load cases, self-weight and live load. Okay, this model yeah, therefore I have a model prepared. I will open this now. Yeah. As we are now focusing on the design, I prepared the geometry. If you want to see the definition of the geometry more in detail, you can have a look at this online training at the previous session from, I think, May or June. We will also show you a link to that later. So what we have here now is the slab, and we have here the places where the columns are, and I use now a special support type. The aim of my analysis is that I want to analyze the slab. I don't need detailed information for my columns or walls, and therefore we have a special support type. I will double click on it and I will show you. I did the same thing as for the beam. I selected a node. I said I want a support there, and here I can define a new support. And in the support, I have the option to say stiffness via fictitious column. And when I activate it, this tab opens. And here I can give information about the column that is actually placed there. And yes, I prepared this. We have columns 40 centimeters width and height. The column height is 3.25 meters, and we have the material C2530. And what the program does now is, with these values for the material and the geometry, stiffnesses are calculated. So our columns that I showed you, they are now considered as stiffness, because I don't need any detailed information about the loads within the column or the displacements or something. Okay. So I did this for all these nodes where I have columns. I now have these special nodal supports. And we have this for the walls as well. I double click on this. We have here the option, if we have a line, we can say this line shall be supported. And if I click on the support, this tab opens. And here I can define my line support. And I have the analogous option. I can say I want to define a stiffness via fictitious wall. And then I have to again give the input for my wall. We have here 24 centimeter thick walls and a wall height again of 3.25 meters and the C2530 for the wall. And again, the program calculates stiffnesses. We have a stiffness in Z direction, and we have a stiffness in X direction, in the direction of the length of the line. And this is agreed, and we have it at all the places where the walls were placed. Okay. We have the C3037 for the slab, and we have sections. These sections are used for the ribs, I will show you. And what a slab needs is a thickness. It's the analogous thing for surfaces. We have to define sections for members, and we have to define thicknesses. I can also show you the dialog for surfaces. Here we have 24 centimeter thick slab. Yes. And here we have our L-beams. I will open one. Here I have this special member type rib. Before we used beam, but for our L-ribs that work together with the slab, we have the special type rib. And this rib can also be seen here. Here is shown to which surface this rib belongs. And here I have to select again the section. This is fine. Okay. So yeah, my geometry is defined, and I will have a look at the loads. We can go to the dialog for loads. Again, I'm using the combination wizard, and I have my load cases. This is my self-weight load case. Okay, and we have here our live load. Yeah, and again we have our load combinations as we saw before. I agree to this, and here also I have loads prepared, I think. Yes, I have self-weight that is calculated automatically, and I have an additional surface load, we can see here, for the live load. Yes, and this is the automatically calculated self-weight. Okay, so now again the input for the finite element analysis is prepared. Now we have to give the design properties for that slab. Therefore, I double click on the slab, and I didn't activate the add-on. So I go on base basic objects. I can open base data here, and I have to activate my concrete design add-on. That's why I couldn't find design properties. I don't need this. And yes, this is fine. And now you can see the navigator will change. We have here concrete design types and here the configs again. Now I can double click on the surface and here I have design properties. We again have here our concrete durabilities and from these resulting concrete cover according to the standard we chose. We have concrete design properties. Here you define in which direction the first direction of the reinforcement shall show. For our example now, it's along the X direction. Okay, now we go to surface reinforcement, and here we can define a new surface reinforcement. And here we also have types. I will now use the type on surface. This is the material which is automatically used, our reinforcement steel. And I want to use one that is assigned only at the top. And it shall be in both directions. And we have a look here. Yes, it's okay. It can stay this way. I will now we will at the top take 8 every 15 centimeters, 8 diameter of the rebars and every 15. And I will copy this. And at the bottom, we will assign a diameter of 10 in a distance of 15 centimeter in both directions. Okay, now we apply this and say, okay, now we have surface reinforcement assigned. And again, we have here our design configs and we have deflection settings that we can keep. Okay, and for surfaces, you can find in types for concrete design also the reinforcements listed. And you can edit them directly from here. And here we have the configurations. I open configs and you can see that you have here settings for surfaces. And you also can define different settings, for example, for walls, different settings than for slabs, but we don't need this now. We only have one type. Okay, now my input is done. We also can display the types for concrete design and we can see that we have a reinforcement here. So I start the design again here from the table, concrete design. And now I only want to check the ultimate limit state and I say yes, analysis can be done. Actually, the analysis is more fast. It's due to the use of GoToWebinar, it's from time to time more slow. Now we have this view and I switch off the types for concrete design so that we can see the result better. We again also go to wireframe model and yeah, here we have our navigator for results. I also have again here my overview with the red entries and I go to design ratios on surfaces. And I can see we have several also for fulfilled design checks. And I want to use another type of display so you can see our results more easy. And I also want to switch off the values on surfaces. I want to show them later. Okay, so what we now are looking at is the ultimate limit state design check for the longitudinal reinforcement on the top side of the surface. And we can also look into this is direction 1, this is direction 2, and this is the bottom side. And we can see here that we have at the bottom side, we don't have problems. We also can see it from the table. These two design checks are less than 0 and we don't have problems. We again have problems at the bottom side, at the top side. It's actually similar to our beam problem we have at the supports. Not enough reinforcement in the top side due to the moment that creates tension at the top of the slab. So then we can do here the same thing as we did for the beam. We can add reinforcement at these zones in the top side. And this is what I want to do now with you. We go to the navigator. We have here surface reinforcements. Then I can say I want to define new surface reinforcement. And for these additional surface reinforcements, we can use another type. We will use the free rectangular reinforcement. I can select the surface and I can say that I want to use in both directions a diameter of 16 with the distance of 15 centimeter, and I only want to use it at the top. Yes, and then I have to set the location of this rectangle and the dimensions. I will use the center and sides definition, and I can select a position. I use this node, yeah, as you can see, and the dimensions shall be in A direction 4 meters and in B direction 3 meters for our example. Okay, I agree. It deletes the concrete design results, and we can see I activated the display of the reinforcement. We have now additional reinforcement here. And I can now deactivate the surface, the reinforcement on surface, and I can see here my additional reinforcement. What I do now is I press Control and I click on this reinforcement and I can drag it to the next node. Like this, I can copy it and I can drag it to here and here, because I have the same problem at these positions. There I can also, no. Okay, so now I have my additional reinforcement and I can do the analysis again. What we also can set here, we can see in the table the input data for concrete design, and we can see the selected design situations. In this model, generally in all models, you can do a right click here on concrete design and have here global settings. And in this model, I can deselect the serviceability. Today I don't want to look at it. Yeah. And then you have here the tab and where you can have a look at the objects to design. And I don't want to do a design for the members, only for the surfaces, and punching design for some nodes. And I will now, as an example, show this node and this node. This node, okay. And you have the nodes here. Then I also have to double click in the nodes and activate punching design properties. They have default settings, it's okay for me. Yeah, okay. Now I can, did I do it? No. Okay, I do the analysis and we can have a look at the results. Okay, we go to the results for surfaces and I again deactivate the display of the reinforcement. And now we also can, like for the member, we can have a look at the reinforcement and we will check the reinforcement that is not covered at the top. And we can see due to this additional reinforcement, there's no covered zone, some singularity points, but no not covered reinforcement anymore. And also if we go on the design check, it looks much better. Here, this additional reinforcement should be placed better, positioned better, or yeah. Okay. What I did also was I activated the punching design for design checks for these nodes. These results we now also can have a look at. We can see here our punching checks and that are not fulfilled. So this is a thing that should have that we should have a look at more in detail. We can go here, design ratio on nodes, and you can also here go to design check details. And yeah, check this proof, check yeah, the input, and maybe some additional reinforcement would help. If it's not helping, then it can be that you need a special punching reinforcement and so on. But for today's example, for now, this shall be it. This is the first step. I also showed you for the member. We did the ultimate limit state checks and we looked at them. After these are fulfilled, then you can also have a look at the serviceability and then the detailing proofs. And as you saw, you can in the navigator for results also change the type of display. For example, if you want to do a report, this type of display can be helpful. And you also have the option to display values on surfaces. This helps for printout also. Yeah, a lot of settings you can have a look with more time, more in detail. But this is it as an introduction that I wanted to show you for today. At this point, I would like to end the part of the program. I want to shortly have a look with you at our website. At our website, you can find several things. You can, for example, find the download for the free students version. And we have a lot of stuff like FAQs, frequently asked questions, and we also have some knowledge base article that can be quite helpful. For example, here for punching design, and you can find some further videos and so on. It can be helpful to have a look. And after this training, we will provide this presentation for you. And I put some links for you in here. We have a tutorial for concrete design that can be helpful, and we have webinars that go further. And this is the link to the previous training where I more in detail showed the giving of the input for the geometry of the slab, if you want to have a look at. Yeah. So this is it from my side. I hope this was helpful for you as an introduction into the concrete design with RFEM 6. I do thank you very much for joining this online training. Yeah, and I wish you much joy with static analysis and design with RFEM 6. And for today, a nice evening. Thank you very much, and bye-bye.